Hi there, Mr. Sutton here, bringing you the IM3 Honors Chapter 1, Quiz 1, Extra Practice Number 1 solutions on evaluating functions. For all of these problems, we are being given a function and something to plug into the function. So that's what we're going to do on each of these, and then we'll just simplify after we plug in. So if I'm doing p of 2, that means I'm erasing and replacing this r here with 2's wherever I see an r. So I've got p of 2 equals negative 4 to the 2 times 2 power. So I just put in red here what I replaced. And now I can simplify this to 2 times 2 is 4 up there. And then negative 4 to the 4th power. Let's see, that's going to come out positive because we have an even exponent. And 4 to the 4th is 256. For this next one, we have the z function, and we're plugging 10 into that wherever we see this d. So z of 10 is going to be d to the 3rd plus 5 times d, or 10 squared. So 10 to the 3rd, 10 squared. 10 cubed is going to come out to 1,000. 10 squared is 100, so we do the exponent first, and then 5 times 100 is 500. And then 1,000 plus 500, that'll be 1,500. For this next problem, this is a little different than the last two. You'll notice here for this z function, they're having us plug in something that's not a constant, so this 2s minus 4 expression. So I'm going to replace the s in this s squared with 2s minus 4. So we have 2s minus 4 squared now, taking the place of s squared. We still have that minus 7 at the end. And to expand this, because I have to simplify this, I'm just going to use my a squared plus 2ab plus b squared shortcut. So square the first thing, that's going to be 4s squared. Multiply these two items together and double that. So 2s times negative 4 is negative 8s. Doubling that gives us negative 16s. And then square the last thing, negative 4 squared is positive 16. And then don't forget you still have that minus 7 at the end. So the only thing we have to combine after all that is just the 16 and the minus 7, which gives us 9, to go with the 4s squared and the minus 16s. On this one I have the y function into which I am plugging a 2 for b. So we have 4 to the 2 plus 2 power. That's really 4 to the 4th. This is kind of familiar. I feel like we did this in number 1. This is going to be 256. Next up, we have the n function into which we're plugging this negative 6s expression. So I'll replace the s here with negative 4 to the 2 times negative 6s. And 2 times negative 6s, that's going to be negative 12s in exponent land. And there isn't really much more we can do here. I mean, I suppose we could make this a positive exponent, but there isn't really any need. So we're just going to call this one done. For number 6, we have the z function. We're plugging y plus 3 into that one. So I'm going to rewrite this as 4 to the 2 times y plus 3 minus 2 power. So that's one big exponent up there. Distributing, we have 4 to the 2y plus 6 minus 2. And then the 6 and the 2 can combine to give us a plus 4 up there. And that's going to be as good as it gets. For number 7, we have the r function, and we are plugging s squared in for s. So this is kind of tricky. So I'm going to write negative 6, and then in parentheses, s squared squared. So this s gets replaced by an s squared. We still have the original squared there. Minus, now we have 2 times s squared. So s squared squared is going to be s to the 4th. We multiply the exponents. So we have negative 6 s to the 4th, and then we'll just have minus 2s squared, nothing fancy going on over there. For number 8, we have the d function, and we have to plug 10 in for h wherever we see that. So we have negative 8 times 10 squared minus 10 times 10. 10 squared is 100, times negative 8 is negative 800, and then negative 10 times 10 is going to be negative 100. Combining all that stuff gives us negative 900 for our final answer. For number 9, we have the s function. We're plugging y minus 2 in for y there. So this is going to be negative 8, and then instead of y, we've got parentheses y minus 2. Distributing that, we have negative 8y plus 16, and that's as good as it gets. For number 10, we've got the g function, plugging negative 5m in for m in this. So this is going to be negative 5 m parentheses, in a parentheses there, cubed, minus 3 times parentheses negative 5m squared. Negative 5m cubed, we have to cube the negative 5 and the m separately. So this is going to be negative 125m cubed. And then over here we have to square the negative 5 and the m first before we multiply by negative 3. So this is going to be 25m squared times negative 3 now is going to be negative 75m squared. These are not like terms. They both have m's but different exponents, so this is fully simplified. For this next one, we have the z function, plugging 2 in for w in this one. So we have negative 11 times 2 squared minus 9. Let's follow PEMDAS, exponents before all this other stuff. 2 squared is 4. 4 times negative 11 is negative 44. And negative 44 minus 9 is negative 53. Here we go with our final boss battle. As these things are measured, this is not a very intimidating one here. We have the d function, just got to plug negative 2 in for the 1m that they gave us here. So 11 times negative 2, which gives us negative 22. So that's it for this extra practice. Hope you enjoyed it. Till next time, this is Mr. Sutton signing off.